equations by using the quadratic formula, day 2. Our essential question today is, how does the discriminant help you determine the number of solutions a quadratic equation has? Now the discriminant is b squared minus 4ac. So you may happen to remember that that's the part of the quadratic formula that is under the square root sign. So when you look at the entire quadratic formula, this is one piece of it. B squared minus 4ac. And it's all over 2a. So the part that's under the square root, called the discriminant, controls the number of solutions that there are to a quadratic equation. Because there aren't always two solutions, like the problems that we worked on yesterday. If the discriminant represents a number, the discriminant is greater than 0. So if it's a positive number, anything greater than 0, there are going to be two unique real solutions. And those two solutions, remember, on the graph would be the x-intercepts. So this graph of the quadratic shows that it crosses the x-axis twice. If the discriminant equals 0, if it equals 0, so the square root of 0 would be 0, then there's only one unique real solution. What that means is that the vertex point is on the x-axis. So it doesn't cross the x-axis, it has a vertex on the x-axis. The third situation is when the discriminant represents a number that is less than 0, which means a negative number. Because the discriminant is under a square root, and we cannot take the square root of a negative number, it should make sense that there will be no real solutions. When you're in Algebra 2, you will learn about imaginary numbers, so then you will learn how to solve quadratics that have negative discriminants when you're in Algebra 2. But for now, what you need to know is that if the discriminant is negative, there are no real solutions, which means your graph does not cross the x-axis. It's either up above the x-axis, opening upward, or down below the x-axis, opening downward. All right, example number 1. State the value of the discriminant, then determine the number of real solutions of the equation. 5x squared plus 2x plus 1 equals 0. Just like with our quadratic formula, we need to identify a, b, and c. Now we are going to simply plug them into the discriminant, b squared minus 4ac, and solve it. b is 2, so 2 squared minus 4 times a, which is 5, times c, which is 1. 2 squared is 4, and in the order of operations, we always do our exponents first. Then we can do all of our multiplication. So 4 times 5 is 20, times 1 is still 20. 4 minus 20 is negative 16. So our discriminant is negative 16, which means that there are no real solutions. No real solutions, because it's a negative number. Example number 2. Our discriminant on this one is not written in, well, our quadratic is not written in standard form. So first, we need to move the 12 over by subtracting it, and then we can determine a, b, and c and solve for our discriminant. Okay, b squared minus 4ac. I'll plug in my values. 10 squared minus 4 times 3 times negative 12. 10 squared is 100. Negative 4 times 3 times negative 12 is positive 144, because there's a negative on the 4 and on the 12. So 244 is the value of our discriminant. Because that is greater than 0, there are two real solutions. Example number 3. A is 9, B is negative 30, and C is 25. plug them into the discriminant. B squared minus 4ac. Negative 30 squared minus 4 times 9 times 25. The order of operations, exponent first, negative 30 squared is 900. And then if we multiply negative 4 times 9 times 25, we get negative 900. So 900 minus 900 is 0. The value of our discriminant is 0, which means that there's one real solution. Now the directions have changed on our next example. We're going back to solve using the quadratic formula. Round your answers to the nearest 10. So, to solve using the quadratic formula, remember we need our quadratic in standard form. So I'm going to move both of the terms from the right-hand side over to the left, which changes their signs. Now I can find A, B, and C and plug it in the quadratic formula. X equals, the opposite of B would be 12 plus or minus the square root, negative 12 squared minus 4 times 2 times 18. All divided by 2 times A, 2 times 2. Okay, simplifying under the root. This is a review of what we were working on day 1. The square root of negative 12 squared, that would be 144, positive. Then minus 4 times 2 times 18. That happens to be negative 144. So, underneath my square root, I have 0. The square root of 0 is, of course, 0. And adding or subtracting 0 from 12 isn't going to make a difference. So we've only got one solution. That solution is 3. 12 divided by 4 equals 3. If you don't believe me, you can separate it and solve each one of these, and you'll see that they're both equal to 3. So our only solution is x equals 3. So if we were graphing this problem, we would find the vertex on the x-axis. Our last example for today, A equals 2, B is negative 1, and C is 5. X equals the opposite of B, plus or minus the square root, B squared, minus 4 times A times C, all over 2 times A. So under my square root, negative 1 squared is 1. Negative 4 times 2 times 5 is negative 40. So 1 plus or minus the square root of negative 39 divided by 4, if we are solving the quadratic formula and we find a negative discriminant, we know that there are no real solutions. So no real solutions because the discriminant is a negative number. So we're done solving. You cannot finish your quadratic formula. So on your homework today, were you ready to write your summary, answering your essential question? And then on your homework, the first part of the homework, you are finding the value of the discriminant, and you are saying how many solutions there are. On the second part, you are solving using the quadratic formula. So please make sure that you pay attention to when the directions change. So don't forget on 16 to 22 that you need to solve completely. So they're not just asking how many solutions there are. That's the end of lesson 9.5, day 2.